And it gives us the understanding of why we're doing this. Like, great, professor, you told me I'm going to reject it with this. Sarah, and you said it perfectly, but it's like, why? You know? Why is this the case? Everything was based on probability. So this next test is, it's a probability test, and it's called the p-value test. Oh, go ahead, Michael.
How did you get the sample mean again?
The sample mean was given to us from the textbook, from the former version. That's where I grabbed this problem. But those three researchers went out and got body temperatures over a 3-day period. And of all those body temperatures, that was the mean of those actual humans. Now, it was done over 20 years ago. But it really was done. It was reported, it was published and everything. Cool. Any nurses in here? Know about this? Rick, you get this? The Journal of American Medicine Association or something like that. All right. Everyone, but it was published back in '92. We are now going to put up a little wall here. Everyone, we are going to perform the p-value approach. All right. Yes, we'll do both. This complements us. Even though we already know the solution. Isn't that funny, Sierra? We already know the answer. We know the answer. This is going to complement this because the p-value is important to us.
So you're only going to have us do one of these on the test or both?
Yeah, you'll do both. You'll do both of these. It's not bad though, Gary, because we'll use the technology to facilitate this. We'll be all right.
No. Okay, so you were doing it the long way first, again?
He always
Let me finish this, and then I'll get You'll be all right. It's not bad. Hey, we're now going to perform the p-value approach. And when the p-value is a probability. So that's the first thing. We got to know what the p-value is. The p-value is a probability. Well, the p-value is a probability. We want to know why we're doing this. Why were we rejecting a null here? This being in the critical region. So we're going to perform what's called the p-value approach. So we start out by finding the p-value. And the p-value, everyone, is a probability. I'll show you, we're going to write the number right here. The p-value is the probability that, and when I'm looking for my x-bar, where is it?
98.2.
Right there. And this was on the left side, left tail test. This is the probability that x-bar was less than or equal to 98.2. And I'm going to write this again. Didn't we already find a t-value associated with that?
Mm-hmm.
Yeah.
So I'm now going to put what was the t-value associated with our 98.2? I'm going to write it underneath.
Negative 15.1.
Some of you might have a sense of this probability in your head, but we'll use the calculator to get this. Okay? What I'm basically saying here is from this marking over to that side, what portion, what area of this bell curve is shaded? And it's not much, is it? Not much is shaded over there. This is going to be a very, very, very low number. Because as you're thinking about this right now, you got to be thinking, how much to the left of negative 15 standard deviations is shaded under that bell curve? Oh my gosh, it's not much, is it?
Yeah.
So I want to expect a very, 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 very what?
Small number.
Small number. Do you all agree? We'll do it on the calculator, but we know right now, just looking at this bell curve, we know about the empirical rule and everything. My gosh, this is going to be very, very, very small. Do you agree? All right. Very, very small. So how do I do this on a calculator? Do you remember we always used normal CDF on the last test?
Mm-hmm.
Well, that dealt with z-scores. That dealt with z-scores. We're now doing what? T-scores? So we're going to use something called TCDF. Cool? We'll use TCDF. Now, does everyone remember the things we always had to do? Was it 1E99 or negative 1E99?
Negative 199.
We use negative 1E99 for negative infinity. What's this t-value here?
15.1. Negative 15.1.
15.1. And then
0 and 1.
we'll just put the degrees of freedom. Will that work?
Okay.
What was the degrees of freedom for this?
699.
Let's try. Every calculator has the TCDF button. Well, right now, take a moment before I pop it up here. Would you look under distribution? See if you see TCDF.
Number 5.
Now, don't we all agree we're expecting a very small number? I mean, so small, probably close to what? Think about this. How far from here to the left is shaded? Not much, right? Isn't 99% in here? 99% is in here. There's not going to be much here. So expect something puny, really small, like these small probabilities we get. So let's go to here. Secondest. Let me get that. I hit second bars. TCDF. Not normal CDF, but what? TCDF. All right, what's the lowest number? Negative 1E99. Whoops. Let me delete that. Negative 1E99, comma. Negative 15.1, comma. What's the degrees of freedom?
699.
We're expecting something very small. I wonder what the calculator's going to say. It was so small, the calculator went to what? 0, which makes sense to us. And when we're saying the probability is what? What chance?
0.
All right, so I'm going to put 0%. You can put a squiggle if you want to say it's about 0% chance. Because a p-value is a probability. And before you get so concerned, when you're like, man, that's going to be hard to remember all this, you watch. You know how we wrap up these classes? We go, isn't there a cool button that could do like 90% of this? And we're like, yeah. And Gary, we're going to love that. So don't worry about that. But what's important to us is, this number is so important to me as your instructor. I want to make sure everyone understands this. This is a probability, right? This is what this whole hypothesis test was based on. It was based on chance. And what we're saying is this. Everyone in the world was saying the body temperature was what? 98.6. These 3 researchers disagreed. They probably took body temperatures and thought it was a little what? Lower, like, you know, somewhere around 98.4, 98.3. So they went out and took all these measurements. What did they get for the sample mean? 98.2. Now that is lower. We all can see that. Do you all agree it's lower? What we're looking at in this course is, we know it's lower. We want to know if it's statistically significant. All right, so I'm going to repeat that. You can put that in your notes. It's really important. This is what we're looking at. That's lower. Yeah, we get that. We want to know that this number being lower than this, is it statistically significant? You know, do we have evidence to show that this is statistically significant? The only way we can come up with that is through this probability value, which is a p-value. This is going to tell us. And you go, what are we looking at? Well, what do we consider rare in this world? What have we used in the textbook?
Less than 5.
Less than 5%. But these 3 researchers said, what's going to be rare? Anything less than what? 1%. So, and here's how it goes. If your p-value that you get, if it's lower than the alpha level, then you're going to reject the hell. Let me say it again. If your p-value is lower than the alpha level, you know, we're going to reject that null hypothesis. Now, you want to know why? Here's what's going on. If we're going to probability that there's a 0% chance of getting this, but didn't the researchers get this? Let me say that again. The chances of getting this sample right here, the odds of getting it, is the same chances of me dying today and having my house burned down and having 2 heart attacks and a stroke in the same day. Now, is that going to happen?
No.
But this really did happen. So we're like, then something must be wrong then. What's wrong? We're saying that's wrong. Does that make sense?
0% chance that is.
There's a 0% chance that someone could go out and get these results right here, approximately 0, if this is really the real deal. It's with an if statement. If this is really the real deal. So we go, oh, well, you're getting 0%. Nothing in this world happens with that 0% chance. So what's going on? You must be messed up. Because we really did get this. We're saying the chances of getting this, with that being the population mean, is basically what? 0%. So there's our argument. Isn't that cool? And they use this stuff in law. They do. They'll use this stuff in the courtroom. Garrett?
The level of significance is always given, correct?
Absolutely. Great question. Great question. He says this will all be given. If Gary went out and did his own study, and if he did it with a team of people, you're going to determine before you start your level of significance. You might use 0.05. Most problems use 5%. I guess these 3 were really serious, huh? They were like, hey, it's got to be less than 1%. But boy, that's less than 1%. Does everyone agree? So great job. Hey, we are now going to interpret this because this gives us meaning to this whole problem. Okay? So here it comes. Oops. I'm going to interpret the p-value. All right. Why are we doing this? This gives us meaning to this whole problem. We now know why we're rejecting the null hypothesis. It was based on probability, right? All right. Interpret this p-value. This is the probability. See, that's the first thing. We know it's a probability, right? If you don't like the word probability, you can say chance. This is the probability of obtaining these statistical results. Wow. These statistical results. This is the probability of obtaining these statistical results. And by me saying these, I'm talking about right here. So if you want me to just draw a little arrow here, what do I mean by these? This stuff. That right there. This is the probability of obtaining these statistical results. And then I'm going to put this really big. If! If mu is really, truly 98.6 degrees Fahrenheit. That was the status quo, right? And I'll put a period. I'll put one more sentence. But this is my first sentence. This is the probability of obtaining these results here, of getting them, going out in the world and getting them, if mu is really what? 98.6. Now I'm going to put the word because. Where I went, because the p-value is lower than the alpha level. So I get to change chalk. And what's the alpha level? The level of significance. What was it?
0.01.
So I'm gonna, because the p-value is lower than this guy, this was 0.01, but wasn't this lower? This was what? 0.
0.
0.00. Because the p-value is lower than this is where I like to make this final statement. We reject H naught. We reject the null hypothesis. Or if you want to say it, we reject ho. And when I know it sounds funny, you know why I say ho sometimes? It helps students remember this. Here's a phrase, I'm telling you. Because you can get confused, you get a test, you go, oh my gosh, I'm confusing this. I'm getting confused on a test. Well, how about this phrase? If your p-value is low, reject the ho. I mean, it may be something that'll just help you remember this, right? If your p-value is low, what are we going to do? Reject the ho. And then just remember, if my p-value is low, I'm going to reject it. And you go, well, how low? Lower than the alpha level. So when you go, well, how low? Lower than the level of significance, the alpha level. I know, and I'll say it next class too, so people always remember this. If my p-value is low, I'm going to reject the ho, right? We're rejecting you, we're saying you're out, we're going check mark, we have evidence for this, right? Actually, we have strong evidence, right? Oh, and let me say this again. I didn't write this down, but you can if you want, Sierra. You could really write this. This means our results are statistically significant. That's something, I'm sure you've heard that before, probably in your other classes. You've probably read about this in literature, or in just some of your, your readings. Maybe it's in a biology class, science class, etc. But our results are statistically significant. We all can see that this is lower than that, right? We wanted to see by that being lower whether the results statistically significant they are. Now, you know what's interesting to me when this whole study was done? It really was done. But to this day, guess what everyone tells me? I go, what's the mean body temperature? Everyone still says what? 98.6. I mean, sometimes numbers just what? Stick around. Here's the second thing I'm curious about. This problem used to be in his textbook. He took it out. So now I'm wondering why. I got to get an end. If he came to visit here a couple years ago, the author, next time I see him, I'll ask him. I want to know, like, was there evidence of what? Maybe there was some confounding factor in that study. Maybe it wasn't random enough. Maybe they took all the body temperatures and it was freezing cold in the room, right? You know what I mean? Something that confounded the situation, and someone said, nah, that study was bogus. And so they threw it out. So I'm curious. Or if he just got tired of having it in his textbook, right? But it really was done. It's kind of neat. I mean, because that's strong evidence, isn't it? But to this day, we still say what? Oh, the average body temperature is what? 98.6. So I guess a good lesson to get out of this, don't get too stressed if you have a son or daughter and their body temperature is 98.2, right? Or 98.1. You're like, we're okay. That's okay, right? Hey, now our favorite part. What's our favorite part? There's a lot of writing on his board. I know this is Autumn's favorite part. It's where we say, man, that's a lot of stuff. I've got a conclusion up here. I've got to set up the hypothesis test. I do my interpretation. That's not going to be hard. It's where I might mess that up, right? Or I might forget this TCDF thing, right? No worries. Where is the really cool problem? That's what we want. We all want the what?
Technology.
The really cool stat button. Let's go find it. And everyone, when we do this, you're going to see how much we don't have to do, Autumn. You're going to like this. Gary, I'm telling you, you're going to like this. Now, did anybody need a cell phone snap this? At least we got it on video, right? Are you sure? So it will be on video. Watch what I erase. You ready? Oh, a lot. See all this? Watch it. Calculator's going to do that for me. That cool? So I'll just put a blank.
Look, if we do the extra stuff, can we get extra credit?
It's good to show work, isn't it? Calculator's going to do this for me. Right here. I want to put that. It's going to do all that for me. So let me take this out. It's going to do that for me. It's going to do this for me. Isn't this cool?
Can you give me a solution?
There's only hey, there's only one thing. Everyone, I left it with this yellow chalk. That's the only thing the calculator's not going to do. Will you remember that? Sometimes you're sitting there going,